so when we're talking about mean value theorem for integrals, let's first review what is mean value theorem. What is this like before today when I said mean value theorem? What does that mean? I love that. A rock equals I rock. How else could you put this? Yeah, definitely we could use the formula. But what two lines are parallel here?
This one, tangent and the secant.
Yeah, the secant line, which is 2 points that represents the average rate of change, is parallel to the tangent line, which is talking about the derivative at one single point. In other words, what we used to do for our approximate answer is going to be equal to our exact answer at least one time. That's what mean value theorem says. Okay, mean value theorem for integrals is very much, it's closely tied. You're going to see why we use the same name here. All right, so we've got some conditions. F has to be continuous. We've seen that a lot. We have to have a closed interval, okay? Well, then there exists some number C. We used C before when we were doing mean value theorem. And C has to be between A and B, okay? All that was the same. Now, we'll get to this part over here, but let's look at the picture. Okay, we have this graph F, and we know that the integral is all the area underneath the curve. Whatever that area is, okay, there is some sort of like sweet spot, and it's not necessarily the midpoint. It could be, but I want you to write this out here because it's not, it looks like C is the midpoint to me when I look at this picture. That's not why this is happening. C could be anywhere between A and B, and it could actually be the same value as A or B, all right? But it can't be, you know, outside anything. C is not the midpoint, except in maybe rare cases. But somewhere there exists a C, so that if you found that C, all right, and you go up and you find the point on the curve, and that determines your height. So if you think about it, f of C is the y value. When x is C, that's the y value, that's the height of the rectangle. What mean value theorem says is that the area under the curve, which we do by integrating, is the same as the area of this rectangle. When else did we do area of rectangles? Recently. Riemann sums. Okay? And so let's go over here to this. Then I'm going to explain to you why I think this mean value theorem is so much like this. It's going to help you. And we want to build the concept here because I want to make sure that you understand it. You're going to be more likely to remember it. Because this formula is not going to be given to you. All right? So the integration over here, we know represents the area under the curve. Okay? All right. This part over here is the area of the rectangle. So how do you find the area of a rectangle? Length times width, based on height, you know, however you want to put it. And this is like Riemann sums, okay? But we're just talking one rectangle, one really, really special rectangle, okay? F of C is the height of that rectangle, okay? What's the width of this rectangle? A to B. So how do we represent that? So think of it this way. If we were going from 2 to 10, how far is that? 8. What did you do to those two numbers? You subtracted them. So B minus A, that's representing the width of the rectangle. So that's where we're getting F of C times B minus A. Right? The exact area under the curve, and in all its weird shape stuff, is equal to somewhere this special rectangle that has been placed at the exact point we need it to be placed in. All right? And then algebraically, we're going to find that C. Okay, so it's kind of like before. Before, we took what we used to know, and we said, hey, that what we used to know, which was just approximating, is actually equal to the real, true, exact answer at least once. Here we're saying, oh, area of rectangle, that was approximating, but actually one of those rectangles is exactly right one time. It's the same as the true answer. So this is the mean value theorem for integrating. Okay, in other words, somewhere between the rectangles that overestimate and underestimate the area under the curve, There's a rectangle that is precisely equal to the area of the region under the curve. It's the perfect rectangle. So you pretty much, the thing is, you got to find the value of C that does that. All right, so this says mean value theorem. So I'm going to use this up here, okay? And again, this may not always be given to you, so you're going to have to understand what it means. Just one side's the rectangle, one side's the region under the curve. That's about the irregular shape. So let's think about the area under the curve. All right, that's going to be the integral from 1 to 3 of 9 over x cubed, or I'm going to write it as 9x to the negative 3 dx. Okay, so that's the left side. This is the representation of the area under the curve. That's going to be exactly equal to the area of the rectangle. So to do the rectangle, we need to find f of c and then b minus a, the length and the width of this rectangle. All right, over here, I'm going to kind of take a side step, and I'm going to write down f of c. So for some of you, this would be obvious, that if f of x equals 9 over x cubed, f of c is 9 over c cubed. And I think a lot of people, though, we need to see that. We need to write that down and then use it. All right, so I'm gonna plug that in right here, 9 over c cubed. And remember, I don't know what c is. That's what I'm trying to find. Okay, that's the f of c part. That's the height of this rectangle. Now we got to multiply it by the width. The width, though, is easy. It's just your interval. So you can write it as 3 minus 1, or you could go ahead and write that as 2. That would be okay as well. All right, so let's do the left side. This is what yesterday's lesson was all about, integrating, finding the antiderivative, and then plugging the numbers in. So what is the antiderivative of 9x to the negative 3? Yeah, if you've forgotten, remember you just write the x, you add 1 to the power, you take your existing coefficient, and you divide by your new exponent. That will always work. Okay, I don't need the plus c because I'm going to plug in the numbers, so don't forget to draw that line and then write your 3 and your 1. Okay, over here on the right side, I have 9 over c cubed times 2. All right, so now let's go ahead and plug in 3. So I have negative 9/2 times 3 to the negative 2 minus, and now we're going to plug in 1. Negative 9/2, 1 to the negative 2. And then over here on the right, looks like I got 18 over c cubed. Everybody with me? This whole left side is number crunching now. All right, 3 to the negative 2. What is that? 1/9. So then the 9s are going to cancel. So this just ends up being negative 1/2. Okay, negative, negative, we know that's plus. 1 to anything is just 1. Don't waste your time thinking too hard about that one. Okay, so let's look at the left-hand side. Negative 1/2 plus 9/2. What is that? Which is 4. So I have 4 equal to 18 over c cubed. Now you can either think of this as multiplying by c cubed or cross multiplying, but you got 4c cubed equals 18, or c cubed equals 18 over 4, okay, which I'm going to rewrite as 9 over 2. All right, and so what is just c? The cube root of 9 over 2, and we're going to definitely leave our answer like this. If 9 or 2 were perfect cubes, you know, you could go ahead and do that, but we're not going to simplify that radical. Having a 2 in the denominator, that's totally fine. Cubed root of 9 over 2, if this were a problem where we needed to use that value, we may want to use the decimal version and store it in our calculator, whatever. All right. Look at this next part, though. It says the value of f of c given in the mean value theorem it has a special name. It's called the average value. Now, what was f of c representing in the triangle? Yeah, or what would we say? It's the what of the, right? Did I say triangle?
Yeah, the rectangle is the height.
I just like love triangle living. I always say that. It's the height. Yeah, probably was a trick. All right, it's the height. So before we move on to the next part, if you already knew C, could you find the average value easily? What would you need to do with C? Yeah, we know C is the cubed root of 9/2, so f of C, and I have it written right here, would be 9 over the cubed root of 9/2, and remember that's being cubed from the actual formula. When you cube a cube root, well that makes it easy. Makes it cancel out. And here's the real question. What's 9 over 9/2? It is 2. For those of you that are like, I'm not sure how you got 2, think of it this way. Dividing by 9/2 is the same as multiplying by 2 9ths. The 9ths cancel, you're left with just 2. So that's the height. So we've exhausted this problem. Let's move on to the next part. All right. So this idea of average value of a function is kind of important. It's not just an afterthought. Sometimes it really is what they want you to find. Like let's say if f, if I'm given this f and I'm given all the right conditions, what's the average value? Well, we're given this formula right here. Well, this looks awfully familiar. In fact, I'm going to kind of scroll up, and we're not really going to be able to see them at the same time, but I want you to draw an arrow from our beginning formula all the way down to this one. What algebraically happened from the top formula, the mean value theorem formula, to this average value? The f of c is on the other side of the equal sign, so they isolated f of c by doing what? Yeah, you just divide by b minus a. And so what this does is it's pretty much the same formula, but if all you're trying to find is f of c, then this is really easy because it's like it's set up for you. So like at number 5, find the average value given this function closed interval. It says in all values of x in the interval for which the function equals its average value. We'll get to that second. So we're going to say find the average value. This means we're finding f of c. So f of c equals 1 over, okay, b minus a here. That would be a third, right? 4 minus 1. You can write 4 minus 1 and then write a third. But that's how I got that. Okay, then times the integral of 1 to 4 of this function, 3x squared minus 2x, don't forget your dx. So the average value is just computing this integral, plugging in the numbers, multiplying by 1/3. I would like for you to do this part on your own. All right, let's finish off this problem. So what did you get when you integrated?
X cubed minus x squared.
X cubed minus x squared, and now we got to do.
Yeah, what's that called?
It's just there's different notations. You could sometimes people put hard brackets. It's just the antiderivative. It's still the integral, but you've taken the antiderivative. Now you're going to plug the numbers
What's
in.
the line called?
I don't know. That's a good question.
Could it be called like the integral after the antiderivative?
I don't know. It's a good question. I have to look it up, but y'all can Google it.
Yeah, 'cause that one-
I don't know. I'm sure it has a name. All right, so when you plug in 4, how many of you know what 4 cubed is already before like having to think too hard about it? 64. How many of you, your pre-cal teacher last year or your Algebra 2 teacher required you to know your cubes and squares? At least some of them. It kind of depends. And so this becomes 1/3 of 64 minus 16 because that ends up being 0, which is 1/3 of 48, which is 16. Okay, now the second part of this problem says, and find all the values of x for which this function equals its average value. In other words, find c. If this is f of c, find c. So we're going to take our 3x squared minus 2x, and we're going to let it equal 16. And we just got to solve for x. This is a quadratic. So you got, when all else fails, you got a quadratic formula. But what's the easier way to solve quadratics? Factoring. So I'm going to get everything on one side. 3x squared minus 2x minus 16 equals 0. Now you guys know a lot of different factoring stuff. I think some of you who always do the sum and product and grouping, that's great. But here's the deal. When I see 3x squared, I know that it has to start 3x and x. All right? If you feel like your number sense skills are better now, you may want to try this method of guessing and checking. If not, you're going to do 3 times negative 48, you know, that's, or negative 16, that's negative 48, and you're trying to find the ones that add to negative 2, so that would be 6 and negative 8. So, like my outside and my inside got to be 6x and negative 8x. Do the grouping, okay? I have a video out there about that if you need to. But this tells me I'm going to have 2 here and 8 here, and I want the 8 to be negative. All right, and then just check it. 3x times x, 3x squared. Outside 6x, inside's negative 8x. Together that makes negative 2x. Negative 8 times 2, negative 16. Everybody's good. All right, so that means I have 2 answers. One of them is 8/3, and the other one is negative 2, and I'm done, right? Not done because there's a problem with one of these answers. Let's do it this. It's not in the interval. Which one? That's what we call like an extraneous solution. False positive. It's not a big deal if you know that word or not, but it doesn't, you have to cross it off. It's not an answer. Okay, we only want answers that are inside of one form. Okay. And this tells us about that perfect rectangle. Okay?